Okay, so question 16. So the seasonal indices for visitors in numbers in the theme park were in a particular year were given in the table below there. Okay, in this particular year, 33,120 were during summer. So when they gave a number like that, this is an actual. So sometimes it's better to write what that is, just so you know. So the total attendance for this particular year is closest to. So when they went the total attendance, what they're pretty much saying is they want the total of all the actuals, which would be there's 4 seasons. So all of them added up. So what we say this total of all the actuals. If you look at your formula for seasonal index is actually actual divided by the seasonal average. Oh my gosh, it's so delayed. Okay, so when you were doing that, so if you were finding the seasonal index, that's how you do it. You take the actual and you divide it by the seasonal average. Well, seasonal average, and how you find a seasonal average is you add up all the values and you divide by the number of seasons there is. So that add up of all the values, that's actually what we're trying to find out. So let's have a look at what we've been given. We have been given an actual, so we have that, and we've got this. Now we can actually find the seasonal index for summer. Even though it's missing, we know that this is 1.74. And the reason I know that is because there's 4 seasons, so they should all add up. The seasonal indices should all add up to 4. So if I minus all those other ones, I will get that's how I got that summer one. So now I have the seasonal index. So I could find what the seasonal average is by using this formula here. So what I'm going to say is it's just a rearrangement, really, because the seasonal average, so this one here, is actually equal to the actual divided by I've already done that. Sorry. So we want to know what the seasonal average is. Yeah. So we could find that out. Yeah, I am doing that right. So seasonal averages, we've written that formula over here. So I'm going to find out what that seasonal average is by rearranging this formula. So yeah, so I was right. So the seasonal average is equal to the actual divided by the seasonal index. So if we do that, we've got the actual, which is 33120, and we divide it by the seasonal index, which we've found out is 1.74. And we end up with the seasonal average is 19034. So the average for that season. So now I know what that is, which is here. So I'm going to I need to find out what the sum of all those values is. So if I do the seasonal average times the number, that will give me the total of all the numbers. Total of all. So I'm going to pretty much do this number times 4, which ends up equaling 76140, which is there. Okay, I've put this one. This one's pretty easy, but I just wanted to get the start of the finance going. So, Edo invests 10,000 into an account, earning 3% interest per annum, compounding monthly. So, we really want to be looking at what they're saying, what type of interest it is, or it's not simple interest. So, the value of VN Edo's investment after n months. So they're pretty much asking for the nth rule. So this is compound interest, the nth rule. If you go and look at the formula sheet, it should say this. Okay, so you need to calculate R. So R was, which it's got the formula, is the rate over PPY, which we've got that. There's rate, there's PPY, is 12 over 100. So we end up with 1.0025. So now you can write this rule. It's 1.0025 to the power of n times VO, which is 10,000. So you just look for that rule, and if you have a look, I think it's the only one is A. So just it's that simple. Just go to your formula sheet. When they say find a rule, you must be doing the nth term rule. Now, the effective interest rate is closest to, now I just wanted to recash. Remember, you just put EFF in your calculator, a smooth bracket like that. You put the rate per annum, comma PPY. So they told us up there the rate was 3 and that was 12. So that's simple 3 point, and I think it ends up being 3.04. So just simple, just remember that's how you type that effective, but this is probably a little bit more of the question I wanted to do. So Yolanda purchased a motorcycle for 3,000. She explores 2 options for predicting the value of the motorcycle after 4 years. So option 1, the first 2 years, the motorcycle depreciates 10% using flat rate. And then for the next 2 years, it's depreciated by 10% using reducing balance. That was option 1. And option 2 is you just use reducing balance depreciation for the whole 4 years. Okay. It says for both options to predict the same value at 4 years, the rate per annum used in option 2 is closest to. So what we're missing, so if we look, so we don't know what the rate in this option 2 is. That's the question. Okay. Sorry, so the rate per annum in the second option is what we need. So little r is what's missing here. So we can find out, because that value at 4 years for the option 2 is equal to the same as option 1 after 4 years. So let's go find what the value is for option 1. So the value at the end of 4 years, option 1 is what I'm going to do here. So first of all, it did flat rate. So if we do flat rate, I'm going to find the value. So I want V2. Now, if you look at flat rate and you do the nth term, it looks like that. So it's got D. We know what VO is. So if I just find what D is using the formula, it's rate over 100 times VO. So if you do that, that would be, I think it's 10 over 100 times 30,000. So we end up with the D is 3,000. So if I'm finding V2, it'll be 30,000. Now, it's only flat rate for 2 years. That's why I said V2. So it's 2 times the 3,000. And that equals 24,000. And then the next 2 years is using the reducing balance. So then we do reducing balance for another 2 years. So I'm pretending like I'm starting again because that's the quickest way to do it. So you pretend like you're starting again. So that means the VO I'm going to say is 24,000 for these next 2 years, and then I just use the formula. So I want to do another 2 years where this is the formula for reducing balance, where R equals 1 minus the rate over 100. So the rate was 10% for that scenario. So we end up with 0.9. So this ends up being 0.9 times 2 times the 24,000. So we finally get down to the value of the car, motorcycle after the 4 years using option 1, which is 19,400 and thing. So now we want to know what the rate is using option 2. So we know what the value at 4 years would be, and it's reducing balance formula, so it'll be this. So we go we know V4 is that going to be the same value, so 19,440 equals now the rate. Now we can just use that formula for R because that's what we want to know. So 1 minus little r over 100, and then that's how you find the big R to the power of 4, because this was value after 4 years, times the VO. So it was still valued at 30,000 to begin with. Sorry, a bit delayed there. Okay. Doesn't like me. That's 30,000, sorry. And you can then just use your solve. And if you solve that, you get the rate equals 10.3%. Okay, which sounds pretty okay for a motorcycle. All right.